Hello, my name is Larry Pearson. I'm the Vice President of Marketing at Impetus Technologies, and I want to welcome you to our webinar session today entitled Planning Your Next Generation Change Data Capture Architecture. A brief look at the agenda for today's session. The first thing we'll do is talk about what is CDC. Obviously, being on this webinar, you've already got a certain understanding of that, but we'll just baseline a common definition that will be used throughout the session. We'll talk about various methods for CDC processing in the EDW today and some of the key considerations for implementing a next-generation CDC architecture. Included in this will also be a demonstration of a typical CDC processing flow. And lastly, we will end and reserve some time at the end to answer your questions in a Q&A session there. For those of you who are not familiar with Impetus, just a brief description of who we are, and that really starts with why we exist. And we work with large, complex enterprises to help them improve their competitiveness through the way that they manage decisions, on the way they manage their data toward behaving as a real-time data-driven enterprise. We exist to create powerful and intelligent enterprises through deep data awareness, data integration, and data analytics, as you see here on this screen. And we're able to have the privilege of really serving many of North America's most respected and well-known brands. We serve a variety of industries. You see a few of those identified here on the screen, from major airlines to credit card processors and banking, healthcare, telco, manufacturing, and others. Most of those customers today are part of, would be listed among the Fortune 200. This is also just a reason why we've had so much success working with large, complex enterprises, and that's the fact that we offer a very complex or very comprehensive end-to-end set of big data offerings, service offerings, platforms, and solutions across the full spectrum, beginning with ingestion and transformation into unified data processing for both real-time and batch use cases across data preparation and data access. And in addition to having platforms for implementing advanced analytics, we also have a complete data science practice. And lastly, through a sister company called Kairos Insights, who has a platform, a patented platform that offers low latency BI natively in big data on massively scalable OLAP cubes. So that's a little bit of a view of who we are. We'd like to actually start by taking a poll. We've got a couple of poll questions which will appear during the session, and you see that on your screen now. And the question, first poll question is, what are the different change data capture use cases that are currently deployed in your organization? You see the 5 listed here: continuous ingestion in the data lake, capturing streaming data changes, database migration to the cloud, a lot of activity there right now, and there's certainly a role for CDC to play in that, data preparation for analytics and machine learning jobs, or we are still at that stage where we're using a legacy system, and obviously that's a good reason why you may have shown up for today's session. Before we get started, let me take a minute to introduce our speakers. With me today on this webinar is Saurabh Dutta. Saurabh is a technical product manager for our Stream Analytics platform, which is the platform which enables the CDC examples that we'll be demonstrating later during our webinar. He's a technical product manager, leads multiple engineering and R&D teams, was one of the early team members who helped to architect, design, and now deliver and support the Stream Analytics platform. He's responsible for analyzing complex engineering and business problems with our clients, helping them to manage and develop a roadmap, and providing appropriate solutions which can be incorporated into the product. He brings a unique blend of business acumen and technical knowledge both, and I think that'll come across as you hear him speak. And he helps clients to achieve their objectives here in this area of big data analytics with expertise in big data, cloud computing, and advanced analytics. With him today is also Samir Bide. Samir is a senior solutions architect, also on the Stream Analytics team, and he leads the product engineering portion of that team, responsible for analyzing complex engineering and business problems as well. I'd like to hand the presentation off now to Saurabh, who will take us through the rest of the agenda. Saurabh Dutta, over to you.
Thank you, Larry. So let me quickly introduce you to what change data capture is. So essentially, change data capture is a design pattern that allows you to detect change in one system and pass that same change down to another system. So really, this is used for, in a lot of cases, for replication of databases. So when you have two different data sets and you update a data point in first set, you want that same change to be reflected in the second change. So in any change data capture system, you may want to collect data when you fire queries for creating records, updating records, deleting a record, or actually even when you undelete a record. So in order to keep your target systems in sync with your source systems, you have to start recording all these 4 kinds of different SQL statements. Okay, so let's take a closer look. So let me try to explain this with help of a very basic picture. On the left-hand side, you have your source database, and on the right-hand side, as we discussed, we have the target database that you want to keep in sync with your source database. Imagine you have an online system that is continuously updating your application database. In this case, let's say you have a customer that is registering on your web application. So as soon as the customer registers, he will essentially fill out some information about himself, like telephone number, and that same record is now created in your source database. So once your record is created in your source database and you have your change data enabled, what this would essentially mean is we'll actually submit that change event out to some form of a listener, and that listener can then process that same change and create a record in the target database. Now, as you see, your transactions from the source systems and the target systems, they both have the same customer record, and now they are in sync. So this is the case when you actually create a record. In a change data capture system, as we were discussing, we capture all the other kinds of SQL statements as well. So imagine now your same customer comes back and updates some information, in this case, which is the telephone number. Now, since he has updated the telephone number, which has changed, now this record is updated in your source database. We want the change data capture system to capture this event again and update the record in the target database as well. So this was a very simple example, but when we talk about enterprises, the scenarios are very complex. You have many different teams working on very different set of technologies, and all of them have their own different needs. So what this would mean is when you apply a change data capture system, what you would essentially need is all those systems should now process the data, and in some form, you may want to create a unified system. So all your data is loaded from all these different type of discrete systems. You may have a need to apply in-memory filtration, transformation, and a lot of different types of operators on this data, and your data is processed and then pushed down to a system which is your target system for your CDC-based needs. So there are 2 main important processes out here. So you may want to process your data in batch. Mostly this is done the first time you load your data from your source system to your target systems. And once you have your initial data loaded, then you may want to process your incremental loads in real time. So, that's what, is the need that we are looking at. Now, in a modern CDC application, in a modern system, where does CDC fits in? So in a modern architecture, you may want CDC in a case where you really want to create a data lake and you want all your data in one unified system. So you would want to have continuous ingestion in some form of a pipeline, and you would really want that pipeline to be automated as well. You may also be in a need where you want to really analyze your streaming logs for any sort of issues. So in that case also, you may want to push your data into some sort of a queue like Kafka and Kinesis, and this could be an endpoint where you may want to read data and process it. There could be also a need where now you want to now go to cloud from your on-premise system. So when you want to do this kind of migration, in these cases as well, a change data tool might be needed. You may want to also create some sort of analytical applications with things like machine learning, and you may want to analyze your logs and get some insights over how your data is behaving. And lastly, you may want to have change data capture in a legacy system, and you really want to upgrade and modernize your architecture with the newer set of technology. In those cases as well, CDC has its applications. Now let me take you through some of the common methods to perform CDC. And let's also have a look at some of the challenges that each of this method brings in. So the first one is having database triggers. In this method, when we use database triggers, you can use to perform CDC using some sort of shadow tables. These shadow tables may store the entire row to keep a track of every single column change, or only the primary key is stored with the operation type, like it could be insert, update, or delete. So this operation type is stored along with the primary key. The use of database triggers to perform CDC again has some challenges. So when you fire a trigger, you store all the changes in a shadow table. This essentially introduces an overhead. In extreme cases, CDC may introduce an overhead up to 100%. So you really have to be aware of this. The lower overhead alternative is to only store the primary key of the table. And as I just said, but when you again go back and you really want to see what is being stored, you have to perform some sort of a join to retrieve the entire data set. So this will again have an impact when you retrieve the changes. And also the second thing which it will bring in is you will lose all the intermediate changes if multiple changes took place on the same row. In cases where the source application performs a truncate, then chances are that the trigger won't fire and the changes are not recorded as well. The second approach is using date modification stamping. So many transactional applications keep a track of metadata in every row, including who created the record or the most recently modified row, as well as when the row was created or last modified. This approach to CDC in such an environment is essentially to keep a track of all the changes when it was extracted the last time, and in subsequent run, filter on the date modified column and only retrieve the rows that were modified since the most recent time the data was extracted. This approach also has few challenges. So data deletes again become a challenge over here because there is no date modified for deleted rows unless deletes are logical and you update a flag in the row to indicate that the row was deleted. The extreme case of delete is again truncate, which is although uncommon in transaction applications, but it does occur sometimes. So date modified again must be available on all the tables and must be reliably set. Database triggers may be a good way to set the values, but these may again introduce an overhead on the transactional applications. When you have date modified kind of CDC in place, again extracting the changes uses a lot of resources. So date modified may be, you may want to, evict this, and in some form you may have to index the record. But, when you do indexing, you may have to have some sort of a select statement, but it will also come at some cost, and you may have to continuously update the additional index that you created. The third approach for CDC is based on log scanning. So transactional databases, they store all the changes in transaction logs in order to recover the committed state of the database in cases where database has crashed for whatever reasons. So log-based CDC takes advantage of this particular aspect of transactional databases to read changes from the log. Although there are certain challenges, but again, this is the most preferred way of doing CDC over others. But again, the challenges are, how do you interpret the changes of the transactional logs? Because it is really difficult to interpret these changes because there are no standards on how the changes are stored. So transaction logs from different database vendors are completely different. And there are many scenarios that that come in, and you should consider all and test it. Database vendors, they may not provide any interface to these transaction logs, and even if there is an interface, it might be slow and resource intensive, so you really have to be careful there. There are some, implementations which come in with, databases like Oracle, so there is an implementation called LogMiner. But again, with the challenge with these kind of implementation is with every new release, the way the change data capture is handled is completely changed. So you really have to take care with every new release of the database. And also, when you introduce supplemental logging, there might be a very little impact on the performance of the transactional application, even if there is. So, these are the three major ways how you could do change data capture. Now, let's go through some of the steps that are involved in this process. So, the configuration of the database, this may vary a bit from database to database, but at a very high level, the process remains the same. So, the first process is, the first step is how you enable CDC on the database. So we need to enable CDC on the entire database by executing some commands, and this now lets you record the changes. So this is typically done once per database. The second step is, having a table that, in some form, you need to create some internal tables that can hold the current state of various objects. So this table will be used to track the CDC load information so that you only pick the recent change each time the incremental load package is run. In lack of something like this, the load will take place and the entire data set will be captured each time a sync is initiated. The third step is you prepare the table for CDC. So at this step, you again fire a set of SQL statements and enable CDC on source tables. Some of these steps might not be needed when you actually go with the log-based approach, but in other approaches, these steps might be needed. Then the fourth step is you define the target. So at this step, you need to define and configure your target database. You may want to push your changes into another traditional RDBMS type system or a NoSQL data store or even a data lake. But depending on your choice, you have to define the target store. When you run the initial load, at this step, your job is run and we would have the destination. At the destination, we'll have the table loaded with the data from the source. So in one go, all the data from source is moved to the target. And then we take care of incremental updates. So as we already have the initial data in the target table, now the goal is to get only the changed records. We really have to now focus on getting these changes in almost at near real-time speeds. Now, when you visualize your next generation architecture for CDC, you should really keep some important aspects in mind. The first and foremost is the ease of use. What I mean by this is it should provide a wide range of operators out of the box. And it could be possible that you might have some non-standard requirements, and hence the platform of your choice, it should also provide ways to write some sort of custom logic. And once you implement this custom logic, this logic should be reusable as well. So combining these along with a modern interface, it will really help you to build use cases speedily. The real-time component, what I mean over here is you should have the capability of streaming live updates. So in case of something like Kafka, which is very common to have in a pipeline to push data into data lakes, you should be able to publish live transactions so that in a way the database itself become a live feed to Kafka, or in cloud it could be Azure Event Hub or Amazon Kinesis or some other stream like Mappa stream. So you should have that kind of capability. The third one is the hybrid nature of your platform. So with multiple teams working in an enterprise, each one, it has its own set of preferred technology stack. They have their own set of use cases. So in these scenarios, the preferred platform of your choice, it should be capable of serving in a hybrid environment. So it should be capable of supporting multiple vendors like Hortonworks, Cloudera, Mappa. You should be able to run on-premise or on cloud. And you should also have the ability to ingest into a wide variety of data stores. So now CDC, if you do it through a tool, it brings in a lot of advantages when we compare it with a script-based or hand-coded implementation. So with efficient incremental updates, you should be able to get rid of all the batch workloads. So when you do a batch load, you are actually in some way disrupting your production application. So ideally, this is done during the off hours, and potentially this goes on for hours. So when you move data from your source to target, it is really a time-taking task. So a good solution, CDC solution, should be very low in impact, and it should rely more on incremental updates with a minimum source to target impact, and you should really not need a lot of batch based capabilities over here. Another value that a decent CDC solution brings on the table is having minimum impact on production. So as we discussed earlier, with the log-based approach, whether it is your Oracle or SQL server, you have that backup or recovery log that could be used. And now when all the transactions go and hit these logs, in real time you should be able to read and consume those logs. And now, since we are reading just the logs, it really doesn't impact the production. And you should get all your events in your target systems. It should also provide a very high time to value. So you should be able to build your offloading pipelines fast without worrying about scripting. Now, this should really equip your DBAs and data architects with easy tools so that their time is well utilized. By bringing in a good CDC framework, you should also be able to minimize the TCO with no need of highly specialized users to create such applications. You can simply do it over a user-friendly UI and avoid all the time and labor involved in training. Then comes scale and flexibility. This gets back as well to the mainly scripting work that we were referring to. When you change the environment, add new sources and schemas, that requires new coding, new testing before you actually roll out. So with a good CDC architecture and solution in place, you get to easily update the endpoints and make changes in configuration, and the changes are automatically propagated. Okay, so with this, we'll now have a look at the poll results, and I'll invite Larry to announce the results.
Saurabh, thank you very much. You should be able to see the poll results on your screen right now. As you may recall, there were 5 different options for this question that we were asking. What are the different CDC use cases currently deployed in your organization? And we see quite a balanced range of different, and obviously the option was to pick all that may apply. And the most common has to do with capturing streaming data changes, with almost 60% of people doing that today. Almost 50% have either a legacy solution or are doing some amount of continuous ingestion in the data lake, with database migration being 38% and data preparation being 35%. So thank you for responding to the poll. Some interesting results. Sort of any comments that you'd like to make in looking at this distribution?
Yeah, I think a lot of people now are focusing on streaming. So I think one interesting shift in paradigm over here. So when we used to think about CDC, it was always about batch with, legacy ETLs in place. But now, I see that people want to see the changes live as, they are happening, whether it is errors or whether they want to look at, some sort of analytics. Everything is now happening in streaming mode. So this is one important observation that I could see from the poll results, Larry.
Excellent, and that's actually a great lead-in to Samir now, who's going to come on and talk about an overview of how CDC can be implemented using the Stream Analytics platform, and then also demonstrate how that may be done. So Samir, if you'd jump in now.
Thank you, Larry. I'd like to introduce Stream Analytics. It's a visual platform for creating, managing, and orchestrating ETL and real-time analytics flows. It's basically an accelerator platform for Apache Spark programming. And we have successfully used the platform to address the complexities and challenges involved in CDC implementations for our customers. Now, keeping in mind the functional and non-functional considerations in creating a CDC solution, I'd like to walk through how Stream Analytics addresses those challenges. So when you talk about CDC, there are 3 major stages to a CDC solution. Those are data acquisition, data processing, and data persistence. Finally, at the end, data quality, data lineage, and performance metrics also provide all the necessary auditing capabilities for all the 3 phases of a CDC solution. Speaking of data acquisition, chain data sources are diverse. And as depicted on the left-hand side of the graphic, these can be structured data sources like RDBMS or unstructured data like message queues, for example, Kafka, sources from the Amazon or Azure or GCP clouds. And again, these sources can be on-prem or in the cloud as well. Often the data streams, again, need to be reconciled with the latest data at rest, such as your own database of records, or maybe data at rest on the file system as well. So once the data is acquired, a processing stage takes care of stream correlation, stream correction, enrichment of your existing data using data marts, and data quality and analytics. Finally, once the data is acquired and it is processed, it can be persisted, or it can be processed and again persisted and sent to the secondary data source. And then again, these data sources vary based on the application architecture and requirements of the downstream systems, such as reporting, iCowl, or even data lake ingestion. So where does Stream Analytics fit in? Stream Analytics actually provides a way to easily acquire, process, and store data in the form of Apache Spark visual processing flows. And I'll highlight some of the CDC features in the next few slides. So in order to implement the data processing stages, Stream Analytics comes with some turnkey features. such as out-of-the-box integration with CDC providers and infrastructures. For example, Attunity Replicate users can use StreamAddict's drag-and-drop components to acquire data without having to write any line of code. So you can just drag and drop an Attunity operator, as we like to call them, on the screen, configure it, and you're good to go, and you can start processing your changes in the data stream using Attunity Replicate on StreamAddicts. For batch or scheduled data ingestion, we also have a Oracle log miner interface that enables reading batches of change data capture streams. So like Attunity, you can always again drag and drop an Oracle log miner source or data source onto the screen and configure it, and then you can get started with getting the data from a log miner session. Another common use case for CDC is offloading RDBMS data onto Hadoop. And StreamAddicts has a Hadoop reconciliation operator that allows storing streaming data in Hive tables. So using a single operator enables creating staging Hive tables and merging them with streaming data to create final tables in Hive. So if you have, let's say, an Oracle database and you want to offload it to Hadoop or Hive, using a very simple and basic StreamAddicts pipeline, you can create a production-ready flow. So in addition to data acquisition, and in addition to simplifying the data acquisition flow, StreamAddicts has a mix of analytics and data processing operators that allow users to extend CDC flows just beyond data acquisition. So for example, by dragging operators again on the pipeline, powerful deduplication and complex custom ETL flows can also be built. Also, any visual data pipeline that you create in StreamAddicts is production ready from the beginning. For example, with features like monitoring of the pipeline, auditing of changes to a particular data flow, or even lifecycle management of the Spark flows, you get all those non-functional requirements built in when you create your data pipeline. I'd like to walk through a case study of CDC implementation using StreamAddicts pipelines that we did for one of our customers. The end-to-end solution is basically composed of StreamAddicts pipelines, and with each pipeline actually corresponds to a data acquisition flow. Another pipeline corresponds to a data processing and data storage phase as well. Obviously, all these can be combined into a single pipeline as well, but for the sake of clarity, we've created multiple pipelines. So the first pipeline is actually real-time data capture, enrichment, and raw Hadoop storage. So for example, here we are reading the data from our Attunity channel. Channel is basically a data source in StreamAddicts. And by configuring an Attunity channel, we are able to read the data from Attunity Kafka channels and process it in StreamAddicts. Again, with our out-of-the-box data enrichment process, we can add additional information like timestamp, multiple fields in the records, or any other lookups that we want to do. Finally, the files can be offloaded to Hadoop directly using rotation based on either size or the time of the files. Next is the data denormalization pipeline. So that actually takes care of reading data, streaming data, as well as reading data at rest. And it can join to different data streams and then store the final result in Hadoop. And finally, we can always combine those two data sets, merge them into Hive, and then we do a Hive merge into operation to perform inserts, updates, and deletes over the data. Finally, the final staging Hive table that is created gets stored as a new table in Hive. And all of this can actually be, as I'll show, it can be combined into a two-step process to enable faster results. Sometimes there's also a requirement to not do real-time processing, but schedule your reconciliation flows. So StreamAddicts also has a coordinator flow that allows you to create multiple pipelines and schedule them and create a workflow, a bigger workflow out of those smaller functionality. So this can also be done in StreamAddicts. So putting all of these StreamAddicts together, we have a pipeline that implements all the stages involved in CDC. And I'll basically show a demo which which has a simple Hadoop offload use case as well as a more complicated use case that takes care of machine learning, data offload, data archival, as well as some statistics that get calculated on data. So I will log into the Streamatics Web Studio and show a couple of pipelines. So let me log into the Streamatics Web Studio. So as you can see, I'm logged into the Streamatics Web Studio. And so basically, the Streamatics Web Studio allows you to create data processing pipelines. And I'm navigating to the data pipeline page now. And I'll show the first pipeline, which is a simple Hadoop offload use case, where we're fetching data from Eternity and storing it and reconciling it into Hive. So Streamatics comes with a out-of-the-box channel for reading data from Eternity. There are additional processors that you can use to create a more complicated processing flow. But here, as you can see, we have a very basic flow, which is reading data from Eternity, and all you need to do is just configure what are your data and metadata processing channels, and you can select how many data topics you want to read. If you're an Eternity user, you'll be familiar with how data is read from Eternity. And if you want to capture changes to metadata, you can configure a metadata topic as well. Behind the scenes, Streamatics will not just capture the event stream, but also look for changes in metadata. Lastly, we have a reconcile operator, which is our Hive operator. Using this, all the change data that is being captured or read from Eternity streams is basically reconciled into Hive, either by using a union, or if you have a more recent version of Hive, you can do a merge into Hive. And all it needs is a series of configuration that allow, that users can use to basically select the table in which the Hive is going to store the results, as well as certain key things such as join conditions, as well as what are delete operations that can happen in the stream. So as you can see, using a simple two-operator pipeline, you can create a Hadoop offload solution in Streamatics. And obviously, when you save and play this pipeline, it gets executed as a Spark-enabled flow on your Yarn cluster with all the usual bells and whistles that come with Streamatics, for example, auditing, multi-version support, DevOps support for managing the life cycle of the method. All this is available in Streamatics out of the box. So let me take a more complicated use case beyond just offloading to Hadoop. Let's say you want to, on the streaming data, you want to, not just capture and reconcile into Hive, but at the same time, maybe you're, in your batches, you want to do some kind of machine learning flow, or you want to, store some statistics in different data stores. So for that, we have a somewhat complicated pipeline, again, built over Streamatics. So as you see on the screen here, I have a somewhat complicated pipeline. Here, just for the sake of variety, instead of reading from Eternity, let's say we have a log miner set up in the organization. Let's say you have a Oracle 11G, R2, or a 12C setup, and your administrator has set up a log miner for you. Once it is done, you can actually use the Streamatics log miner data source, as you can see here, and configure the tables and the operations that you need to record data. And once you're done, you can do a series of operations using the Streamatics drag and drop processors that you see here. Let's say you want to raise some alerts or calculate aggregates of how many inserts or the rate at which deletes are happening in the database. You can use our out-of-the-box operators, just drag them to the screen, do some basic data filtering, and then maybe store all those statistics in a Hadoop environment or even on an indexing store like Elasticsearch so that you can display them on the UI. Additionally, the same data stream gets replicated and maybe sent to a machine learning flow. For example, here I'm using a k-means operator to do some kind of a bucketing on the input stream that is coming in. And the results get stored in the native HDFS. And the reconcile for Hive that I showed earlier stays as is. So effectively, I'm reading data from log miner, once, and I'm processing it in 6, 7 different stages in stream analytics without having to read it so many times. From a CDC standpoint, the source here, like I said, is LogMiner. And in LogMiner, if you're using even if you use a pluggable data source, Streamatics has support for pluggable database. If you use a 12c instance of Oracle, you can always select that. And based on the connection, for example, here we are using a JDBC connection or an additional database of that I've configured as ORC here. I have a bunch of tables in this schema, and one of the tables is employee salary, let's say. All I have to do is select that, configure how I want to read the data. For example, I'm interested in insert, delete, and update all the 3 major operations on the data store. I can select them, or I can select only one of them. I also have the capability to choose how long or how much data I want from a single read into a LogMiner session, and what should be my maximum transaction time that I want to sniff using this LogMiner session. So all of these and some additional tuning parameters like buffering and the maximum records that make up a batch, I can select all of them, and the data will be received at the pipeline and will be processed inside Streamatics Apache flows. Additionally, like I said, you can do other things as well. For example, you want to do deduplication of the data, you can simply drag and drop a dedup processor and introduce complex ETL flows in your CDC environment. So at the beginning of the poll, we had questions around, what are the typical use cases for CDC? So I think within these 2 pipelines, we're able to demonstrate or at least show how you can do CDC in Streamatics using for the purpose of machine learning, for the purpose of, let's say, analytics on the data, statistics calculation, offloading to Hadoop, as well as reconciling to a different data source, Hive, or this could actually have been any other RDBMS as well. So a set of 2 pipelines in Streamatics, built in Streamatics, ready for production, can solve a variety of CDC use cases. So, in the webinar, we wanted to emphasize on what are the key components and the challenges in realizing your next-gen CDC architecture for enterprises. To summarize, a next-gen modern CDC architecture should focus on unification of various phases of a CDC implementation. So basically, a successful CDC implementation should acquire and process data in real time, not just acquire data in real time and then have a series of processes that will do ad hoc processing on data. So unification is the key. It should also enable read once and process the capture stream as required by various downstream systems. As you saw in the pipeline, we were reading the data once from the Oracle LogMiner session, but we are processing it multiple times. Also, effectively, the solution effectively should enable data engineers to do more with the data acquisition flows. So this goes beyond just capturing data and doing a lot more with your data. To conclude, obviously the benefit to business is huge, is enormous if the entire data stream is captured and analyzed in real time, as opposed to the legacy CDC use cases where data is acquired but then is processed by 5 different means. The benefit of having all of your data present, or the most recent data present in real time, is enormous. CDC is a complex problem, obviously, especially with the data updates and the rate at which data changes in an enterprise, and that is going to grow, as data volumes become huge and huge. And lastly, when creating a CDC architecture, also look at or analyze platforms that enable rapid development and operationalizing your complex CDC flows, and not just a bunch of handwritten programs that enable or have a very skewed view of what the ultimate goal is for an enterprise.
Samir, thank you very much for that interesting discussion of how easy it is to do CDC processing and define those flows using stream analytics. We're getting ready now to transition to the Q&A portion of our webinar. You have time still to submit any questions that you may have. In addition, this is the time in our webinar when we would like to ask you to provide us with your feedback on your experience today. The last poll question that we're going to present and ask you to respond to, you should see that on your screen here now, and it basically says, would you be interested in a deep dive of Stream Analytics as shown in this webinar? And as I say, we also very much covet your feedback on your user experience today, rating that from 1 to 5, with 5 being the highest. Now we'll transition over to answering the questions that came in during the event today. And let me just pull up the log of those. There's a number of questions that have come in. The first says, is there any impact on transactions being written by production applications as we're applying CDC to those? And sort of if you would go ahead and take that one on.
Sure. So a log reader, it only does reads on the transaction log. It does not log the log file or anything, log the log file at all, yeah. So there is almost no impact on production tables or on the application writing to the log. So in a way, I could say that there is almost no impact on your production application.
Oh, okay, great. The next question that we have says, how long should the captured data be kept on the target databases?
Okay, so this really depends on your use case. So how long do you want to keep that data? So it, based on your hardware capacity or business requirement, you may decide for how long you may want to keep that record. So you may eventually have some sort of a script or something which will move the data either out or to some sort of a historical store. But it mostly depends on your hardware. And you can always define some sort of policies on your target systems for how long you want to keep that data.
Okay, great, Saurabh. The next question is actually directed over to Samir. And the question says, how do you accommodate schema changes into the source databases?
Yeah. So basically the way Stream Analytics works is specifically for CDC, we have a canonized way of storing changes to the metadata. So for example, if I take an example of Acuity, if changes to the metastore are captured, Stream Analytics has its own way of, so we have a canonical data format in which we store all metadata information, and we use the underlying whatever pipeline the user has built. Those schema changes are transferred transparently over to the next in line processing that you have in the system. So effectively, the way to do that is to basically build your own schema. Right now, for Stream Analytics, this happens out of the box. But if you were to do it on your own, you would actually have to hand code a lot of stuff in there and keep track of how schema is changing over a period of time. So that's automated in Stream Analytics.
Okay, very, very interesting. There's also a question here that if I lose my data in the target system, is there a way to recover it back from the source databases? And that's directed once again over to you, Samir.
Yes, there is a way where you can, so effectively we're saying, so another way to put it is is there a way to replay the series of events that have happened on the database onto Stream Analytics again? And it's a combination of what we support in Stream Analytics as well as any other change data capture stream sources. If you have your own way of passing on events to Stream Analytics, we recommend building a secondary pipeline that will have a staging queue or something where we can log events and replay those when needed. The other way of doing that, for example, if you're a logminer user, you can go back in time and select a time range or even a SCN number where you want to read that. So you can reset and offset in Stream Analytics while reading data from Stream Analytics CDC channels. That applies to both at Qnity as well as LogMiner.
Okay, very good. That's interesting. And I know we talked several times about the LogMiner capability that's included in the Oracle database. We have a question here that says some databases like Microsoft SQL Server provide CDC by default. How different is what we're doing from using one of those solutions?
Yeah. So throughout the course of this webinar, we have been focusing on three things really. Data acquisition is just one of them. The other two major things being data processing and data persistence in a polyglot environment. So I know MS SQL has a way of supporting CDC. Even DB2 has a way of, or there are products from vendors from those databases that support CDC. But this is really beyond data acquisition. What we are talking about here, you can do machine learning, data processing, custom ETL. You can build your idempotent or non-idempotent stateful ETL flows using stream analytics. So the value add here is what to do beyond data acquisition.
Okay, good, great, thank you. Another question that came in says, how do you maintain a record in the target if in the CDC the record is deleted in the source? And Samir, that's directed over to you as well.
So you can actually have a pipeline that stores data in record, and you can choose not to detect deleted. You can actually filter out deleted stream and store it in a secondary storage. For example, in the pipeline that is stored in LogMiner, you can filter out delete actions and divert them into a secondary data store if you want. So you can do kind of stream filtering based on the event types and then store them accordingly.
Okay. All right. Great. There's another question here that says, do you support replication between two or more different database types? For example, source being Oracle, target being DB2. Sort of, if you could address that.
Yeah. So in terms of databases, we do support a number of different types of databases. So you could definitely move or replicate data from one type of database to another. And one thing which I would like to highlight over here is we do expose certain interfaces in stream analytics. So essentially, even if the database is not commonly used one and you have something very peculiar, so what we can do is always implement a set of interfaces which have very easy life cycle type of methods in it. So you could just implement that, and we could support any source and target over here, and it is just a matter of a week or two, and we can have that support in stream analytics. So that is not that big a challenge.
Okay, great. There's a question here also for Samir. It says, does stream analytics handle databases such as Salesforce.com records?
Yeah, so stream analytics has support for structured and unstructured data as well as a variety of data sources. Salesforce is a peculiar case. We have the ability to query a Salesforce as a database, so you can actually write SQL queries against the Salesforce topic. However, so in cases where out-of-the-box drag and drop functionality is not available, stream analytics also comes with its own custom implementation, which can be customized based on the data set provider. For example, Salesforce is an example of that, where you could just, by changing a few lines of code and registering an entity in stream analytics, it becomes a reusable UI component that users of the platform can use as a out-of-the-box component for data ingestion. So Salesforce is in that category. So we do have a Salesforce custom implementation to read data from Salesforce.
Excellent. Samir, the next one came in and is directed to you as well, and it says, is there a scalable way to extract changes that actually took place and to indicate what changed in near real time? Often database updates only update a few columns, and some users may not be interested in those columns, so we want to identify what it is that changed. And Samir, that also is for you.
Okay. So basically the question is somewhat similar to, do we have a lineage sort of a functionality or reverse lineage sort of a functionality in Streamatics? So we do have a way to capture events coming in and how the data is changing within a pipeline. So for example, you insert a database, you insert a row in the database with some 10 columns, and then 3 columns get changed later. We have a lineage capability that allow you to go back and search for a particular key in your data record and see how that data got changed in the Streamatics pipeline. So if you have a business flow that is changing the data within Streamatics, you can use our functionality of reverse data lineage. Also, for changes that happen outside of business logic created in Streamatics, we have been doing this for some of our large enterprise customers, where we actually have implemented a polyglot persistence architecture, which allows you to record and display what changed in data in almost real time.
Okay, great. There was another question, Samir, that said that you referenced Attunity several times during the webinar. What more is in Stream Analytics that adds to the function that may come with Attunity CDC?
Sure. So yeah, Attunity Replicate is a CDC solution in itself, but the way we use Streamatics for CDC again goes beyond data acquisition and basic pipelining. For example, I talked about how you can do machine learning on the captured data stream without having to go through the data stream multiple times. You can do in-memory processing, create powerful deduplication flows using your custom logic or the ones that come pre-packaged in Streamatics. Or you could, use things like, if you want to mask data or prepare your data for auditing and things like that, you can use ready-made flows. So this goes beyond the kind of complicated ETL flows we can build in Streamatics offers a huge value add.
Okay, great. Listen, that was a great Q&A session. We have a few more that trickled in, and we'll be sure to answer those out on email. Our time is up. As you see here on the screen, you have the opportunity for a free desktop download at www.streamanalytics.com, as it's shown here on the screen. On that same site, there is also the opportunity for a cloud-based trial. And if you have any other questions, you can reach us at inquiry@streamanalytics.com. Thank you very much for your attendance and your attention. This concludes today's event.